So hi, this is my first talk ever, first time being in Poland. A lot of firsts for me this week. I'm really excited to be here. It's really awesome to see all you. It's been really fun to meet a lot of people in the community. Thanks. So I want to start off with a story. So it's probably something you can all relate to, where you're upgrading some dependency of your app, and if you're lucky, you really quickly encounter a screen that looks like this. And I say you're lucky if you encounter a screen like this quickly, because that means you probably caught it early and it's not going to get shipped to production. But if you're unlucky, then you really see this in like crash logs or user reports, and it becomes a little bit of a bigger problem. So this is pretty frustrating. I hate when this happens to me. It happens to me all the time. But there's ways to avoid this, and there's ways to make this easier, right? So when this happens, you have to go look at the change log for the dependency that you were upgrading, and then you need to look at the breaking changes and audit your entire code base for the things that changed. And you have to see any of those places that you use that breaking changed function, you might have to update. And so it's very frustrating and time consuming, and doing that manually is just like not a modern solution to that problem. So today in my talk, I'm going to show you how you can use type systems to avoid that. But more importantly, you can use type systems to guarantee more consistency in your UI. So I'm Jordan. I work on the Flow team at Facebook. Specifically, I work on our React model and our object model. So since I work on our React model, I get to read a lot of React code. I talk to a lot of people who write React code every day, and my job is basically to make it easier to express the patterns that they want to express in types. So this whole talk is type system agnostic. I'm talking about higher level ideas here. It's not specific to Flow. You can apply all these ideas in TypeScript as well. But that said, all my code samples are going to be written in Flow, because I don't know TypeScript and I know Flow. But the high level ideas are going to be applicable to both. So I saw this on Twitter, and it was shocking to me, because I don't know why this number is so high. Yeah. That's surprising. And I also think that on Twitter, more people tend to use types. So the real number is probably higher than that even. So very surprising. And the goal of this talk is to, if you're in that category, to get you out of there. It doesn't matter which one you choose. I just hope you get out of that category. And also, if you're already using a type system, I'm going to build up to some really cool patterns you can enforce with types. So there's two parts to this talk. The first is I'll show you how types make your life easier. And the second, I'll show how types will make your users' lives better as well. So without further ado, here's some reasons why you should be using a type system. The main reason that people will tell you to use type systems is because type systems catch bugs. That means as you're coding, there's way less mental burden you have to keep around in your mind to think oh, well, what if this data is null? Or where did it come from? What if it's a string? Could it also be a number? You don't have to worry about any of that. The type system will, all those tiny little gotchas, it'll just catch them all for you. You don't even have to think about it anymore. But more importantly, or maybe equally as importantly, your code reviewers who have to read your code later also aren't going to have to worry about those things. Instead, both you and your reviewers can focus completely on the task that you're trying to do, and not the tiny details that tend to trip people up as they're writing code. Also, as your team grows, you get more of these weird invariants and things running around in your code that you have to kind of have this collective understanding on your team of all the different possible execution paths and the weird types of values that you can encounter. But as soon as you start expressing those in types, it becomes easier for people who join your team to say oh, I now understand that this function sometimes returns null, so I always have to handle that case. Type systems also catch breaking changes. So in that first story, when you upgrade some external dependency, you would also upgrade the types for that dependency. And any breaking changes that got to the type level, which is often where breaking changes are reflected, would be pointed out in your code automatically by the type system. So instead of having to manually audit every single place where you use that library, you can just let the type system do that for you. Also, if you're a library maintainer, or you're working on some internal code that's used widely in your own code base, then when you make a breaking change, you'll also be notified immediately as you're making the change of all the call sites that might need to be updated because of your changes. Types are also a great form of documentation. So for you, you can basically read a function name, look at the input types and the output types, and you'll already have a great idea of what the function is going to do at runtime. But also, it's great documentation for the machine. Types are like comments that can never go out of sync, right? Because you can have some type for a function, and then as soon as your function no longer conforms to that signature, the type system will tell you, hey, either you're trying to make a change that is wrong and it's going to break things later down the line, or maybe you actually meant to change the signature of this function. Types also enable a very good developer experience. So Radek talked a lot about this in his TypeScript Our Future talk yesterday. That you get crazy more functionality when your IDE knows more about the values at runtime. So just as an anecdote, a couple of years ago, like 5 years ago, I was at a hackathon, and I was on my team. My job was to write a Swift app. I had never used Swift before in my entire life, and I was basically like just totally out in the deep end. So as I was writing code, I realized that I could basically just rely on the Swift autofix suggestions to write the app for me. And so despite like having programmed for like 24 hours straight in Swift, I came out still not knowing Swift, but having a like working app. So that was pretty cool. And that was all powered completely by the fact that Swift has great types. So before I continue, I'm going to say the word invariant a ton in this talk. It's a term that I use all the time. When I say it, I'm talking about properties in your program that you always expect to be true. And so an example of that is you might have some array somewhere that you say should never be empty. And so an invariant of your program is that that array is never empty. Bugs aren't just runtime errors, right? It's not just those crashes. Sometimes when you get an invariant violation, those also show up as bugs. So if you had that array that you said should never be empty, but some execution path led that array to being empty, then that can show up as a bug in your app as well. So let's concretize that a little bit. I'm going to show you how you can encode some invariants through a type system. So I'm going to implement a non-empty list, and I'm going to protect the implementation, completely protect all the data in there, and ensure that it's always not empty by using these types. So here, I created an opaque type to represent the list. The underlying structure of my non-empty list is going to be a pair. The first element of the pair is the first element of the list, and the second is the rest of the list. So as long as I can keep this structure, I'll know that I can always access the first member of my list. So I made it an opaque type, and an opaque type in Flow means that the structure of the underlying type is visible only in the file that defines it. So outside of this file, I would have no idea that it's implemented as a pair. And this is very important to hide this implementation detail, because if externally you could access the underlying representation, then you could manipulate this value in a way that would break the invariant that I'm trying to protect. So this is also, opaque types are a Flow feature, but TypeScript recently announced like some nominal type, and I'm sure it could be used to accomplish the same thing here. So other than defining the data type, I need to give you a way to create it. And so to create a non-empty list, all you have to do is supply the first element. And then here's an example way that you can manipulate the data. This by grabbing the first element of the non-empty list. We always know it's going to not be undefined because by definition the list is not empty. I guess it could be undefined if you're storing a list of undefined, but that's a weird use case. So types are really good at two things. And these are more important than catching those runtime errors. The two things that they're really good at are creating abstractions and enforcing invariants. Right? So I created an abstraction with that opaque type. You can't access the underlying structure. All you can do is use the interface that I expose. And since I can prove to myself that my interface always preserves the invariant that that list is never going to be empty, I can ensure at runtime that that list will never be empty. So if you can start encoding these explicit invariants in your types instead of having these implicit invariants going around in the collective knowledge of your team, then you can start really enforcing these higher level properties at runtime. So there's also a lot of invariants in your UI that you probably want to preserve. And if you don't, then they end up making it to the screen, and you get some really weird looking stuff. So this is a very exaggerated example of invariant violations in style. But my entire slideshow had a theme. Here I have fonts that did not fit that, colors that are not in that theme. Spacing is really weird. And this is the kind of stuff that could also happen in your apps. And it might not be as egregious as this, but over time, you can make small mistakes, and then eventually they all pile on top of each other, and you have one weird-looking page in your app that looks completely different from the rest of it. So to enforce your own invariants, there's two important steps. The first is you need to find the information you want to protect, and then you just need to make restrictions on them. So let's see how we can start enforcing invariants for React components. Here's an example component. It's pretty simple. And there's two important parts that we need to look at to start enforcing invariants about it. The first is the props, which is the input to the component. And the second is the return type of the function component, or equivalently, the return type of the render method on a class component, which says what the component renders. So when we're talking about props, this is already going to handle the vast majority of the invariants that you're looking to enforce in your design. So if we look at this example, can I have Wi-Fi?
Please don't turn it off. Don't press it.
Thanks. Yeah, I'm confused about how I'm even connected without Wi-Fi.
Yeah, if we turn it off. Oh. Okay.
Okay, try.
Yeah. Thank you. All right, that was shocking. So let's say I'm writing a slideshow component. For my slideshow, I'm making some slideshow text component, and I'm going to put it in my slideshow. So here, I'm passing it a green color, and that does not fit at all with the rest of my theme. So if I want to start enforcing some color scheme invariants across my slideshow, I can model that as a type. So in my slideshow, I'm saying that you can have gray, blue, white, and black text. And so instead of accepting any string for color, I can now say that I only accept colors in my color scheme. And I get an error when I try to pass a color that does not conform to that color scheme. Right? But if I pass something that's allowed, I don't have any errors. But enforcing the props type is not the only important part of enforcing invariants in your React components. The way you compose your components also matters a lot, right? Because you might have two collections of components that are not meant to be mixed. So in this example, I have these non-tab bar buttons inside my tab bar. They clearly don't belong there. They stick out. They look weird. And we can avoid these kinds of situations using types as well. The important information that you need to know in order to restrict these compositional properties is the element that your components are rendering. So here I have a component. I say it renders a React node. In Flow, React.node means the most general thing that you can render. So anything will fit here. So if I were to also render something that's not my button in this function component, then that's OK as well. But if I wanted to always enforce that the component that I'm rendering here is my button, then instead of rendering any node, I can say that I would only allow my button components to be rendered. And then I would get an error. Now, these errors don't necessarily mean that you're rendering the wrong component. It could just mean that your design changed and that you need to propagate those changes to the types as well. So I'm going to concretize that a bit more and show a more real-world use case, where let's say I'm a component designer for some core components in my app, and I'm making a menu. And this menu can have menu items and menu separators. So the menu items are going to be clickable buttons. They'll have an icon and a name, some text. And menu separators will be like a thin gray line that separate blocks of these menu items. So this is an example of something that we want to avoid. In this screenshot, the big red box represents some component that does not belong in the menu. Right? Everything else is OK. There's like thin gray lines here that are hard to see because they're very thin. And then there's also buttons on this menu. But we want to make sure that we could never even possibly get this red box into our menu in the first place. So I have a small app here. And I'll show you how you can start to enforce these compositional invariants through this app. So all this app does is render that menu that I was talking about. And so we have some menu items and some menu separators in it. It's pretty. Sorry, 1 second. So we have menu items and we have menu separators, and we compose them to make our menu. But, so if we run flow right now, there's going to be no errors. But if we were to add in some non-menu separator here, like maybe it's just not a menu component, save, we have that red box, exactly what we were trying to avoid. Right now, if we run flow, there's still no errors. So let's go figure out why and how we can restrict this from happening. So if we take a look at the menu and how we typed its props, we said its children can be any React node. And so that means I can literally render anything that I wanted inside this menu. That's not what my design invariant was. My design invariant was that I can only render menu items and menu separators. So instead of saying that I could render any React node, let's change that to just being, we can render an array of menu items and menu separators. So now when I run flow, I get an error. And I get the error because this non-menu item does not belong inside my menu. So this restriction is extremely powerful, but it's also very strict. Right? So we can completely enforce the kinds of composition that we would allow. But sometimes there's these little compositions that you'd want to allow that what I just described doesn't really capture. So for example, let's say I had a disabled prop on my menu item. And I use disabled equals true a lot. So instead of passing that prop every single time, I make a new button, or I make a new menu item called disabled menu item. And all it does is render a menu item and pass disabled equals true to it. Right? So the invariant that I described before is going to be too strict to allow this disabled menu item inside my menu. So everything looks OK, no design invariants are being violated. But when I run flow, I still get an error. And that's because this disabled menu item is not a menu item, and it's not a menu separator. It's a disabled menu item. So we need to relax the invariant that we're enforcing here a little bit. Instead of saying that we want to only be allowed to render a menu item or a menu separator, we want to say that you render a menu item, a menu separator, or something that itself renders a menu item or menu separator recursively. So that's a little bit more involved, but I implemented a type here that describes that. So I'm not going to go into the details of it so much, just because it's flow specific, and you can probably do something similar in TypeScript, but you can see I'm just looking at the things that are rendered by the component and then making restrictions based on that. So if I were to go into my menu, and instead of saying only a React element of menu item and menu separator, what I want to say is, so I called that type restricted element. I want to say that I can render a restricted element of menu item or menu separator. And again, restricted element means something that renders that element or something that recursively renders that element. And so now when I run flow, there's no errors. Right, so now we've captured this extremely powerful invariant where you can say, like, if you're designing these core components for your app, and they can only be nested in very specific ways, you can make sure that someone who isn't you and that didn't write that component will never make the mistake of miscomposing those components. Also, this pattern is being used a lot in the Facebook rewrite announced at F8 this year. There's a team that has been designing all of the common components for that entire rewrite, and they use this pattern to restrict the composition of those components so that later, when hundreds of other product engineers are using their components, they're not going to run into all these invariant violations that they've worked really hard to capture. So just to recap, types catch bugs. They're going to make your life easier. You're going to avoid crashes in production. It makes reviewing easier, makes onboarding easier. But they also, more importantly, will make your UI look more polished and consistent if you use them to their fullest potential. Picking a type system is pretty hard. There's a couple good options in JavaScript. I recommend doing your research to figure out which one works best for you. Flow and TypeScript are very good at different things. They have a lot of overlap, but they really specialize in different areas. And so I don't care which one you use, but if you're not using one, you definitely should be. Importantly, you don't have to start a whole new project just to start adopting Flow or TypeScript. They're both designed to be gradually adopted onto large code bases. So don't be intimidated by your 1,000,000-line code base thinking you could never adopt types because no giant PR could ever land to add them. So if you have any questions, or if you're not using types and you want to explain to me why, you can tweet at the Flow Type Twitter. I don't have a personal one. Or come find me during the coffee break. I'd love to hear the reasons why you're not using types if you're not, because I don't understand. So thanks.